So all I want to do quickly was just give a little bit of overview as to the way that at Microsoft we're thinking about the issue of cloud and gaming, because we take a little bit of a different slant on it potentially to the way that the word cloud gaming has been used recently. To set a little bit of context for that, I generally think I have a very, very interesting job at Microsoft at the moment. So I spend a lot of my time in the city talking to banks and financial institutions about how they can use cloud computing to add capacity to their risk processing and their Monte Carlo simulation engines they use to work out the risk and pricing of all the complex derivatives which cause the markets to blow up every so often. So interesting conversations then about high-scale computing and the way that you can take account of uncertain workloads by using the cloud as a back end. I also spend a lot of time with retail companies and analytics companies looking at how the combination of cloud plus social media and big data can be used to drive monetization and understand customer experiences. I also talk a lot to companies about how cloud plus the integration with devices and mobile devices can enable remote working and mobile work experiences for individuals. What's interesting is that I'm talking about all three of these things to gaming companies. And I want to give you a little bit of an overview of why and why we see that as important. So there are three broad characteristics of cloud computing I want to talk about, which are very relevant, I think, to all gamers, not just big studios, but also to indie developers and to the two-man shop down the road building an app for a tablet. These scenarios for cloud, I will try and demonstrate, can bring about enhanced game experiences, how you can help create some differentiation, can provide you ability to understand customer behavior and drive engagement, enhance monetization, and critically, even in some cases, enable new kinds of business models which weren't possible before. So I'll quickly run through these scenarios and try and give you a flavor of why we see it as fundamentally driving some differentiation. Set a bit of context. First bit is that just to address the elephant in the room, although I'm talking about Microsoft cloud backend platforms, and I use Microsoft examples, we're very much open in the sense that on the one hand, on the back end, if you want to run your back end services or your cloud services on Linux using PHP and Ruby, fine, we can run that all on Azure. If you want to connect up your devices and your applications on iOS or Android, you can connect them up to services running on Azure. So it's not just relevant if you think about developing on the Windows stack. The story today is about broad patterns and practices. I'm just illustrating it with examples based on the Microsoft platform, but it's an open story. The other bit of context is a bit about where we are essentially in the market and what we mean by cloud gaming. So this data is provided by Nick Parker Consulting. I'm indebted to him for letting me use this particular data and his view here on the market segmentation. So broadly, he segments the markets into these three broad areas. So blue being traditional box games, white being online, including mobile gaming, and then this little thin sliver here of green being the area of download and streaming-based game delivery. He points out a couple of interesting things. I think this year, interesting moment is when the online and mobile revenue becomes bigger than the traditional box gaming area. And the second one being that next year, Nick particularly thinks that buried within here we'll start seeing a bit of a hockey stick moment for some of these cloud-based scenarios for distribution. So what we're going to do is really focus for just a couple of slides on that little green sliver, because that green sliver is where the term cloud gaming really seems to have resonance with people. When we talk about that little thin sliver, what we're really talking about are two specific scenarios. The wonderfully anachronistic VS God, so video streaming games on demand, where the bits coming down from the cloud are actually the pixels. So it's actually rendered video streams coming down so they can be consumed on devices. The other mechanism, other mode here is progressive download, where the bits coming down are actually part of the game. In fact, having downloaded a minimal footprint of the game, what happens in the background is additional parts of the game, levels or episodic downloads can occur to enhance the game over time. And so both of these are really distribution scenarios. And in the video stream games on demand, there have been a number of companies recently that have been making moves in this area, some successfully and some not. Obviously, you've probably heard about OnLive and their business difficulties that they had. There's other companies. We're partnered with a company called Agawai. One of the players in the area here is CNow. This is typical of the proposition for these video stream games on demand, the idea that by rendering the game in the cloud and distributing down to devices as a video stream, you can essentially have the same high-quality experience in respect of a device platform. So for companies like Sony who bought Gakkai, I think they bought Gakkai for about $380 million, for them it's an interesting diversification play. They've got the console games and they've got the titles. By potentially partnering with Gakkai, they can start thinking about distribution scenarios to a whole range of different platforms. The underlying technology behind these kind of experiences is more or less consistent. So the idea that whatever the device sitting behind the broadband router blinking away at home, on the back end, somewhere in the cloud, there's a very large-scale infrastructure to do the video streaming. Excuse me. And so part of it is the virtualized game image. You then have some kind of infrastructure to render the game and essentially stream the gameplay down to be consumed by the devices. But critically, clearly there's a player there with a controller. So there's some kind of interaction feedback which comes back up, back into the game engine. The trick with this is to make sure that that particular feedback loop is quick enough. Because as you can imagine, if you're playing some kind of interactive title, if you have long latency, or at least even a tangible form of latency between control input and the video coming back, the game could become almost unplayable. And that's one of the tricky scenarios around this particular kind of stream game on demand. Overall, though, it's an interesting area. I think that if we can overcome some of the key technical limitations on the scenario, which include things like bandwidth, and particularly in places like the US, bandwidth caps, if we can deal effectively with latency issues and to create effectively lagless control of games, or at least the appearance of lagless control, and also I think address the actual underlying streaming technology, which is where and put it on a strong economic basis. Right now, particularly with OnLive, one of the problems they had was that they had to have one GPU role, essentially, for every player playing the game. And it was beginning to destroy any kind of scalability that could occur in the business model. So I think there's a lot of work to be done there with the streaming technology providers and some of the startups to try and put the availability of this kind of platform onto a much greater scale and take advantage of the scale and the economics that cloud computing can provide. But those issues aside, I think we'll certainly see an acceleration of these stream game on-demand revenues in 2014. Certainly that's Nick's view. And potentially it could become a dominant form of distribution for gaming, certainly heading out beyond 2020. What's interesting for me about that, though, is that not necessarily about the scenario itself, but where it could lead. For me, it turns games into broadcast media. In the same way, if you look at Call of Duty Black Ops 2 with the YouTube streaming channel capability, you can play the game and you can do your bragging rights afterwards by having the game replayed through YouTube. For pro gamers, you can essentially turn it into a broadcast mechanism for the pro gaming community to view games being played. So this idea that we start getting this mashup between traditional distribution of linear media, for example, and for gaming content, that kind of creative mashup into like an entertainment service, I think, is where this particular technology really takes us. I think that's why it's a very interesting area to watch and be an area of a lot of growth. So that's broadly what we talk about and what the industry talks about in terms of cloud gaming. They tend to mean that particular scenario. But our point of view is that actually for both these other areas, both the box games and critically for mobile and online games, there's a lot of cloud scenarios and reasons where and ways in which cloud can be used to enhance monetization and gameplay and experiences. And so what I'll do is I'll walk you through those three sort of key characteristics of cloud and how it relates to these particular areas. To introduce the first one, I quite obviously need to talk about Ant and Dec. And you can choose your own favorite comedy duo. It doesn't have to be these two. But the interesting thing about Ant and Dec is, if you ever watch them, is that first of all, they always appear together. I don't know if they sleep together. I think they live next door to each other or something, even though one was married. And they always stand the same sort of side of each other. But critically, when they actually work together, it's always essentially Ant who does the gags and Dec who's the link man between them. It's an interesting metaphor because essentially, if you talk about devices, you can't do anything else but talk also about cloud. We don't talk about clouds if it's just an isolated thing. You know, it's up there on the internet somewhere. The cloud has to become real at some point. It has to touch people, it has to be interactive, and that's through devices. So cloud and devices are inseparable. You have to talk about one and the other in the same breath. And so the first characteristic really about cloud is that we're living in this world where applications span both the device and the cloud. And literally, it can be almost down to the idea of a slider, right? An application can be predominantly on the device, it can be predominantly on the cloud, or can be some balance in between. And increasing the ability to augment what goes on the application by functionality in the cloud is becoming very powerful in terms of delivering new experiences. So I'll give you an illustration of that. This idea of empowering the mobile app. You have some kind of device. Right? Now, irrespective of the fact that the devices we all have probably have more computing power than sent man to the moon and all the other usual things, the cloud can provide an awful lot of resources and an awful lot of capability which can be used to augment, add to, link into applications sitting on the device itself. I'll illustrate that with a simple example. So we have a game called Path of Go, the game Go. This was developed by Microsoft Research, and I think it's an Xbox title. Go is an interesting game. I think if you play chess, the number of possible chess games that you can have is 10 to the power 60. I think the number of possible atoms in the visible universe is 10 to the power 80. The number of possible Go scenarios that you can play is 10 to the power 700. It's an enormously combinatorially complex game, which is why AI researchers and combinatorial researchers focus on Go now as like the new chess. So Go is the new high ground in machine intelligence and machine learning. So what we have a game called Go. And what MSR are working on at the moment is the idea that potentially you'll have a form of that game sitting on the handset, which is linked actually to the AI, which is back in the cloud. This is a very powerful idea because what you essentially can have is almost a limitless AI. You know, thousands of processors if necessary, crunching the numbers on the back end. All of that AI surfaced by a simple state-based, term-based client on the phone. And so this idea of augmenting the application with capabilities in the cloud is actually very powerful. And it doesn't just have to be AI and number crunching. You could do localization. You could tap into search engines and indexes. There's all kinds of marketplaces, for example, with real-time data, which could be used to augment applications, and obviously aspects of streaming media as well. So this idea that you can take an application, it sits across both the phone and the cloud, and you can start thinking about deploying and building applications across both devices and the cloud is a very interesting pattern. Now, within all those services, there are three key services we're seeing at the moment, or types of service, which are really adding a lot of value, particularly when focusing on the player and the idea of drawing the player in and having deeper player engagement, understanding what the player is doing. So I'll quickly run through what those three scenarios are. First one is identity. Understanding, knowing, linking to players, particularly their social identity, is increasingly critical. Once you know who someone is, and you can understand that they played one particular game and then they played another particular game and it's actually the same person, right? It gives you the ability to start collecting, aggregating data and understanding behavior. So it is actually very important to be able to take someone's Yahoo, Google, Facebook, or even Microsoft ID and use that as a form of authentication so you can start having links in both to consistent understanding of gameplay and the interaction of players with different titles, but also linking into their social media and their Twitter and the other forms of public data which the player will be outputting. So you can start building up a more holistic picture of their interests and how they can be marketed to. So identity and being able to authenticate users using social IDs is an increasingly important part of game design. The second element, relatively simple, notifications. A great way of driving engagement with players and with customers of software is to push information to them. And so frameworks to scalably and intelligently push notifications down to mobile device apps, clearly an important workflow. The final element is data. And of all these three, data is probably the biggest. The ability to use the cloud as the aggregation point of data coming off the devices is utterly compelling, irrespective of what kind of device you're talking about. We have engineering companies who are taking data streams, literally almost gigabit data streams, off wind turbines, taking that data up and aggregating it on the cloud so they can understand weather patterns, the efficiency of turbines, and can optimize the whole design of the thing. This pattern of taking from connected devices, taking data streams up, aggregating data in the cloud, and then using that data to gain insight, right, is a standard thing now which is happening across a lot of industries, including retail, engineering, banking, and so on. So this ability to collect data is a critical element of this story. To give you a quick example, is anybody aware of the True Skill ranking system? This is a simple database ranking system which runs on the Xbox Marketplace, developed by Microsoft Research up in Cambridge. It's a machine learning technique. Essentially, what it's able to do is estimate the skill of a player using a number of different variables over the course of various forms of gameplay, and then use those skill ratings to start matching people in multiplayer environments. The reason this is so important is that actually that drives a lot of great game experience and customer satisfaction on the Xbox Live Marketplace. Rather than just being matched naively with people who are far better than you and you find yourself obliterated in the first few minutes, it's a way of actually making sure everybody participating in gaming and in those multiplayer games actually can have some kind of immersive and challenging experience. And so that ability to collect some data about players' performance in particular games and use it intelligently to create estimates of belief around their skill level has actually been a source of competitive advantage in that particular market. And that's just starting to really sort of scrape the surface of what can be achieved, I think, going forward with this idea of the data-driven business. So if you start thinking about a particular game, the ability to take key performance indicators out of that game, so how long a player is spending on a particular level, are they getting stuck at a particular place, what is the propensity to use particular tokens or buy particular in-game goods and tokens, how is all that potentially being taken up by players? Can you visualize that data in some way so you can understand almost in real time the flow of people through the game and the kind of activity that's occurring? Could you actually, within that, start trying live A/B testing? The ability to update the games on the fly and tune it on the fly would give you the option to say, actually, within a particular level, we'll try an experiment on a subset of users to see how particular tuning of the game might work in terms of giving them a greater propensity to buy some in-game purchase. And based on that live A/B testing, you can then iterate the game out to all players. What this comes down to is the idea that with data-driven insight comes back to the idea of monetization design. Right? When you design the game, you design it with the hooks and the scars, the bolts and the various elements you can optimize, the magic numbers or the control points, such that you're able to optimize the game and optimize the gameplay to drive outcomes. This is supported by the idea of continual release, the fact that titles increasingly now can be updated in real time or can be optimized and tuned, or data-driven configuration, such that essentially you're almost in this permanent beta state, supporting this kind of testing. All of which leads into the end, the fact that what you're trying to do is optimize and drive the average revenue per user or average revenue per player up. And this kind of structure, this data-driven approach to optimizing the average revenue per user is absolutely, I think, where studios are going to have to head in terms of driving monetization strategies. And this is a quote from the chaps at Flurry, I think who are here today, might be speaking next. So hopefully this is like a warm blanket for you. Let me go back up. But I love this quote. In industry that's historically been considered more artistic and subjective, connected devices and the ability to rapidly iterate, right, has ushered in an age of science and measurement. Absolutely right. And to be honest, it doesn't matter whether you're talking about finance, whether you're talking about retail, whether you're talking about transport, airlines, or gamers. Everybody's heading in this direction, right? Data science is now the new rock and roll. And if you look at how much data scientists are in demand across, particularly in the Valley, for example, you can see this is becoming a significant trend now across a broad range of industries. A little sort of background to how we're trying to enable this for game devs. We have something called Azure Mobile Services. Basically, it provides authentication, notification, and back-end data services as a platform. So it's like a back-end as a service for applications, which can include games. And we actually provide SDKs and the ability to access this back-end of a service for both our platform, for iOS and Android. So if you're building a multi-platform title or a title just on iOS or Android, fantastic. You're welcome. Please use our back-end as a service so you can start taking advantage of these particular services in a scalable way and one which gives you some interesting diagnostics in terms of usage. I'll give you a couple of examples. There's a massive multiplayer online game called Illyraid. These guys have recently built a Windows 8 application to surface the game, and they're using the Azure Mobile Services to do push notifications down to the game and player authentication. So they've started on those first two key workloads. And talking to the guys the other day, plan is to, on next title, is to start using the Azure backend completely and also get into this data-driven area to understand more the behavior of players. So they're certainly using this. Another interesting example is from the guys at Mudvark. I'll just show a little video here. This is their game, Watermelon. Are the Mudvark guys here? So, there, guys. Right. Fantastic game. So it's basically throwing melons around at various things. You get the idea. There you go. So built on the Construct 2 gaming engine. Fantastic thing about... sorry. Here we go. Right. We'll get back to where we're meant to be. What the guys at Modern Jago are working with us on is the ability to put Azure mobile services into the Construct 2 gaming engine in a sort of plug-and-play, easily configurable way. So elements of things like authentication, notifications, and some of the data capture out of games written on Construct 2 could just hopefully now be plugged and smoothly put into Azure mobile services. And that, for me, is a kind of direction we'll see. This ability to take data and monetize it will start becoming more of a platform capability and hopefully be integrated very closely with some of the engines, so it starts becoming almost like a democratized access to that kind of capability. So if that's the story around broadly apps and cloud and having the application across both the device and the back-end cloud services, a couple other quick characteristics of cloud worth mentioning. Simplicity and this idea of auto magic in experiences is really important. Cloud is meant to simplify interactions between devices and the capabilities that people experience. So my mum, who's not particularly a great technology user, she was astounded when I first set her up with Dropbox, where she was able to actually synchronize files across her PCs, and it all seemed to be very magic. Right? That kind of idea of auto magic experiences is really important. And I think another little game I'll just quickly highlight here is Chimpact. These guys have been working, it's a fantastic little game. I'm sure the chap will be in the shops for Christmas. What they've done actually is use a very simple roaming profile data feature inside Windows 8 API, so they're able to sync game experiences across different devices, and it just happens with 3 lines of code. The interesting thing about that is it's not a huge amount of effort, but it's got very positive feedback. So this particular comment here in the marketplace, I'll give you 5 stars for the fact the game smoothly syncs between machines. Right? So it's the idea that you start providing real value and you get some real positive feedback and experiences from customers just by doing these simple syncing kind of services. With Smart Glass, we tried to take that in the living room to the idea that you start having shared multi-screen experiences, and that starts becoming very immersive. And that's just essentially a simplified form of the overall picture here, which is that across a range of different devices, the cloud can become the integration point for these kind of seamless experiences. You can start playing a game on your mobile device. When you walk in the house, the state can be picked up by the PC or the slate. Potentially the whole thing could then be rendered onto the TV, or the high-definition version of the battle you just fought could be streamed down to your Blu-ray player and then played using the app on the Blu-ray player. The fact is these connected devices and connected scenarios are going to be a way of driving differentiation going forward. So cloud as a form of differentiation experience across multiple devices, again, is another standard pattern. So finally, the third element of cloud, which is really important to just quickly discuss, is this area of economies and economies of scale. Cloud is really more an economic disruption as a technology one. If you've been to CERN, anybody been to CERN? You've seen this, right? This is Tim Berners-Lee original PC. It has a sticker on it up there, a little post-it says, "Do not turn off, this is the web," right? That was the cloud then in 1990. The cloud now looks a little like this. We build our data centers for Azure in containers. Each of these containers, dependent on the hardware inside it, can contain between 5,000 and 15,000 servers. And we literally wheel them in, plug them in, and we boot them up essentially onto the network, and that's another 15,000 servers capacity in the cloud. It's really an industrial level of scale of compute. What it's really good for is dealing with uncertainty. So if you have workloads where you're not sure what the demand will be, you don't know whether the game's going to go viral and the load will go up quickly, or whether it'll just gently grow, or whether in fact you're going to see a spike in usage, traditionally after release of boxed games, for example, big spike in usage after launch. After that, you tail off to some steady state usage of the game. If you have to support that by some kind of back-end infrastructure, buying and paying for infrastructure at the top level is wasteful when you've got lower usage over here. And certainly in the case where you're trying to allow for virality, it's a very, very expensive game. It's almost prohibitively expensive to do the hosting yourself. So the ability to embrace scale and certainty by paying for capacity, just spinning up the capacity you need and varying that over time depending on demand, is exactly what the cloud is designed for. It's what all that scale there is for. So to give you a couple of examples, WebZen, Asian Studio have got an Arctic Combat multiplayer game, all hosted back-end on Azure. Essentially they run across a stamp of many hundreds of servers on the back end delivering this experience to their customers. Another great example, though not a game, it's more of an interactive sort of literary experience, is Pottermore. This is J.K. Rowling's literary site. again, completely stood up on the Azure platform and was done so to take advantage of the scale we can provide when they were trying to onboard multiple millions of users onto the Pottermore universe over the course of a few weeks. So again, dealing with uncertainty, dealing with scale. And in this, we also eat our own dog food, as we say.
Where are
3 minutes.
And so you come at last. Cortana, what is it? We are forerunners, guardians of all that exists. Humanity stands as the greatest threat in the galaxy. The forerunners have returned.
Last year had a lot of big releases of Microsoft Windows 8, Windows Server, big releases on the cloud, and Halo 4 was one of the sort of highlights of that.
Sorry to hurry along, but I want to make sure people have got a chance to ask questions.
I'll be literally about another minute or so. Interesting about the back end about Halo is the fact it was a mix of the actual box game and a back end called Halo Waypoint. There's a whole stream of telemetry which goes up from the game into Halo Waypoint and enables you to understand your gameplay and the statistics around the matches that you've had. There's also an episodic download called Spartan Ops, which is driven as well to try and engage keep customer engagement over the life of the title. All of that back end is built in Windows Azure. So the guys at 343 built over 40 services covering a range of different functionality in less than a year to deliver this big back end experience that goes with the Halo title. So again, a great demonstration of dealing with uncertainty and scale. So to summarize that, what we're really saying for Microsoft here is that the combination of cloud plus application, cloud plus game, does present a lot of opportunity. I think you can create differentiated experiences. You can think about driving customer engagement, gaining that data insight, and using that to enhance the monetization you're seeing. And potentially, by the use of these sort of new economic and business models and the economies of cloud, you can actually enable scenarios, particularly around viral and social scenarios, which wouldn't really have been economic before. So at that point, I'll leave it.